Alright guys, I'm just about to unbox a power inverter, a solar inverter basically, and I've already crimped my battery cable, so just the last one to do. And just want to show you the process. I would normally use this hydraulic crimping tool, and just gonna cut it to size. Get to the final part, just gonna take it out. And normally at this stage I will just kind of twist it just to make sure the copper is in place when I insert this one. And once at this stage, I'll just get my crimping tool, insert it. Normally I would do this on the floor, but I just want to show you the process. I wouldn't do it on this table. I'm gonna move it to the floor now and get it done. But what I can do is I'll just do it on this table for now until the okay. Now on the side, I've got the adjusting tool here, adjusting wheel. So I'm just gonna turn it on and tighten it, and just keep. Some people use hammer, but I like it neat like this. And now that I can see that the crimping tool is already hold the copper lug, then I can push the cable in and start mounting the pressure. Now, in most cases, you will need somebody who can assist you to hold this so that you can exert your pressure on the crimping tool, because you don't want the cable to be sliding out. The lug is very expensive. It's around £1 or £2, depending on where you get it from. So you don't want to misuse it. Okay, now at this stage I will just kind of put it on the floor because I don't like it. Okay, and I'll hold this down and then put more pressure on it. Use two hands if necessary, because you don't want the cable to be sliding out of the lug when you connect it to the battery and the inverter. I think I'm done. I'm gonna release the wheel here and it's gonna open up. Let's take it out, and this is what you've got. Now this is actually not the best so far because the crimp actually held it from the top here rather from just from the middle, just like others, but that's still okay. It's still very tight. I'm still gonna do it some more from the middle to give it more strength. So anyways, yeah, I will do it from the middle to give it more strength. Hi guys, welcome to this unboxing process of a new solar inverter. I ordered this from powerjack. Unfortunately, they do not ship down to UK any longer for some reason, probably because of the size or the weight of their product. So I had to ship it down to someone in Germany, and the person assisted me to ship it down to the UK. So what I'm going to do now is to get started with the unboxing. Sorry, this may be a bit of a long video because I've got a lot of things to test. I've got two power save batteries here that I need to test in real time. They've been idle for more than 2 days now, so I'm going to do their cold cranking arms test and see if they still have the power they possess the first. So what do we have here? This is certification of conformity. I'll see if I can screenshot this later and post it. What else do we have here? We've got some extra warning. What else do we have here? After sales service, warranty card, please log in USA, blah blah blah. So we've got the manual. I think I have this already all the for the other 8,000 watts. This is 9,000 watt basically. So I think this is actually different. It's the manual for the 9,000 watts. I've got some fuses here. Probably 20 amps or 15 amps, I'm not sure. Now I need to bring this out. This will require some power to do this. Quite heavy. It's about 31 kg, 31 or 32 kg in terms of the weight. So we're gonna pull this aside, put this on the floor. So got some protection here to protect the terminal, which is quite good, so that it doesn't get damaged during transportation. And we've got another one here to protect the front interface. We've got some rubber, some mounting or sitting rubber, which is also very good. The other 8,000 watt that I've got does not come with all this. And some other information here. I'm not sure exactly what they're trying to refer to, AD, whatever. So what I'm gonna do now, let me show you. Just right at the back, we've got two big fans. The fans, just a vent, it's not really a fan. I can see inside. It's not fan, but it's just like a vent. I think there's only one fan right here. Sorry, this is quite heavy. Yeah, there's one fan here. Yes, this is the fan. I hope that this is not going to be making a lot of noise. So this is the only fan we've got for this one. It does not come with any LED panel, but I'll try and get one and install it myself. So I'm going to get started by removing the screws. Okay, I want to remove the two covers that are protecting the interfaces, the front interface where you get your AC power, and the back one, the two terminals. There are four terminals actually for the battery, where you get the for the DC connector. So I'm just gonna get started with this one. What I'm gonna do is remove these three screws, two screws, and whatever we've got at the bottom. I'm gonna take that out. So I'm gonna pause the video. Alright guys, as you can see, I have managed to take off the two protectors, and you can see the screws on the floor. I'm just going to take off this phone from the stand just to give you a closer look. We've got the AC interface there. and the DC interface, 24-volt input, and I've got the fan here. I'm just hoping that the fan is not going to make a lot of noise this time around, because the 8000 watts that I got makes a lot of noise, like an alarm, basically like a siren blaring. So I have to replace the fan for that one, but hopefully this works fine. And I've got my batteries ready as well. I'm going to put it to test again. It's been idle for like 3 days now. Hopefully I'm gonna do the hopefully the cranking amp result will still be the same, or at least very good, and hopefully the voltage has not dropped below 12.6. So we're gonna get started with everything, guys. So now that we've got the interface open up, oh, this part is actually sealed up. Is that screwed or something? Okay, that's all right. Put that back. I've got some fuses here. This is for the battery, this is for the inverter. What else do we have in this interface? I hope the camera can capture this very well, but it's kind of typical of power jack inverter. Basically, we've got the socket output here. We've got the battery voltage regulator. I think this is the AC regulator, so in case you want to put it to 230 or 240, that should be it. I'm not sure what this. Let's focus on this one. So just to let you know again, if you've not seen my previous review on this particular battery, I bought it second hand because I bumped into this power safe of a thing online, and because they said it's made in the EU, I'm expecting it to be of good quality. It was made 19th of April 2019. Today is 2nd of June 2021. So just gonna take this off and I want to give it a try. Now it is 170 amp hour battery. Now generally for 170 amp hour battery, you expect the cold cranking amp to go above 1000, should be between that 1000 and 2000 cold cranking amps. But the first thing we're just going to do is to make use of our multimeter. When I tested it, when I first brought it in, it was testing good, but now it's been idle for about 3 or 4 days, and I'm just going to test it again to see if it still retains its power. Okay, the power is still the state of charge is still the same, 12.9. It hasn't dropped, which means it's kind of reliable in that sense. And the next one here, we're gonna put this also to a test. Now, I'm not sure if the camera is capturing this for you guys. I'm trying to get the camera capture this. It's just dropping, but let's see. All right, just a little bit, but that should be all right. It will do. Now put it on top, and this is also doing 12.9, which is good. Now, as I mentioned in the previous video as well, or maybe I should not make any reference to that in this, just to let you know, before you go and buy your battery, make sure you have this. This is very important. Never use a multimeter. It gives you nothing. It just tells you the state of charge of the battery, but the state of health, the internal resistance, this is going to calculate that for you. Okay. um, so you can get this on eBay or Amazon. It is very important. Now the screen is not very clear, so you may not be able to see this very well, but just hook it up again. Every battery must have cold cranking amps. Now the first thing you're going to see is that this is going to tell you the voltage, the exact voltage of this battery. Battery system analyzer or battery system tester, 12.94 volts. Now what you just do is you click on OK, select your language, English. It is heart of vehicle. Now the reason why you also need this is because you want to know the state of health and how much cold cranking amps does the battery comes with. Now for a battery that is 170 amp hour, as I said earlier, you should be expecting something above 1000 up to 2000 cold cranking amps. Now this is the amount of amps that the battery can withstand before it loses voltage to the point that it will not be able to recover any longer. Now you would ask, why is this important for a battery that you want to use for solar system? It is very important because let's say you're using a submersible water pump, or you want to use your microwave, or um, your washing machine. Now this kind of appliances, they surge at higher rate. So for about 5 or 6 seconds, in order for them to keep their operation going, they will surge times 3 or times 5 of the original rating of such appliance. So you want to make sure that your battery is able to hold is able to hold on to its own power and be able to regain strength to be able to continue running. So we are before charge. I would say after charge because it's already reading 12.9. So I will say after charge and go for OK. And this is a regular flooded battery, so I'm just gonna go. And then the CCA is going to be, I'll put it for 1200 for this, because the used battery normally I'll be expecting around 1005 to 2000 cc code cranking amps, but because it's already a used battery, so I'm just going to leave it at this and put it up to test. Now what the system will do is, this analyzer or the tester will do is it will put some power into the battery and see if it will be able to withstand it. Now it says it's a good battery. The state of health is at 87. The current charge is 12.9. The state of charge is 98. And the current CC rating for this battery is at 1125. Yes. And the internal resistance measurement is at 2.6, which is quite good for a battery that is offering 170 amp hour. You will expect something below 3. Now the lower the amp rating, the higher the internal resistance is going to be. So this is looking good. Now I'm going to do the second one, do the measurement for the testing for the second one. Now what you'll be expecting is to have almost similar value at least, because if this is a good battery, this is not a good battery. When you join them together to make 24 volts, the power of this one, of the lower performing battery, is going to reduce the performance of this to its own capacity. So this the battery that is reading higher is not going to give the best performance, because its own power is going to be operating at the performance of the lower quality battery. So let's do this. Now for this, it's saying that the volt is at 12.87, so 12.9 approximately. We go for language English, out of after charge and regular flooded. It says here we leave it at the same thing, 1200. Now because the voltage for this one is a little bit lower, so I would expect something a little bit lower compared to this in terms of code cranking amps. But let's say, you never can tell, it may exceed your expectation. It's currently testing. Now this is not giving a good reading. It's telling me that the state of health is at 2% and the state of charge 98, and code cranking amps is at 190 amp. So this is really poor, but I'm suspecting maybe because of the way I hook this one. I'm gonna change this around and then give it a try one more time. Regular flooded. Okay, so now I readjusted the terminal here and it's giving me a better rating this time around. Now what does it say? State of health is at 100%, reading 12.8 volt. The state of charge is at 98%, and the code cranking amps is at 1235 amps, which is really good. And if you look at the internal resistance, is giving me 2.42. So basically this battery looks to be very okay. I'm gonna move to the next stage now. All these have completed their work. I'm gonna connect my cables. I've got my cables here. These are 70 mm cables, and they are welding cables. And I've got my lugs as well. I've already crimped them up, and they are ready to go. So because the inverter that I'm using is will require 24 volts, so that means I have to connect this in series, which means I connect the negative to the positive of this one. Okay, I'm gonna need some washer. Alright, they do not come with a washer, so I already have some washers that I bought a long time ago. I'm just gonna use that to complete this process. Take out this terminal. Okay. Now the other two terminals will be connected directly to the inverter. And now the next thing I want to do is to measure these two terminals, both the positive and the negative. and I've got 25.7 volts. Quite good. Turn this off. We have 4 terminals here. I can use any of them. Alright, so I'm just at the final stage of the coupling. One thing I just want to share with you is this. You could see that while I was doing the testing for this battery, when I put the clip on top of it, it didn't read very well until I changed it. Now, what I want to point out is this: you need to ensure that the terminal you're using is a good conductor. If it is not a good conductor, it's just going to limit the power of the battery. Yes, the battery could be working fine, your cable could be very strong, but if your conductor is not very good, that could reduce the amount of power that your battery is going to be giving out, and it can also slow this down, because this will be seen that this is not actually giving enough power that it's supposed to be giving, and the performance of this is going to be reduced as a result. So make sure your terminal is a very good conductor. So everything is looking tight, securely fitted. Now I'm going to connect them one after the other to this. Let me just put it at the top instead of on the bottom one. Alright, that's strong enough. Now the last part is to connect the positive terminal. Now once I've connected the negative, now I've got the positive to connect to the positive terminal. But whenever you want to do this, you're going to get a spark. Some people will call it a big spark, some will call it just a spark or a small spark, whatever it is. But there will be a spark that is strong enough to, to make you feel uncomfortable. So what I normally do is to use any kind of appliance or any plug for any appliance to charge the capacitor inside this battery, inside this inverter. And by the time I connect the positive terminal, the capacitor is already charged up. So what normally happen in that process is that that plug will gradually transfer power into the capacitor to charge it up. So by the time you connect your positive terminal, you will not get that big spark. But let's see, I hope it's going to work this time around. So I connected the light, and that seems to be working fine now. And the lamp is drawing about 13.2 watts. We've got the power on, it's working. Now I can't find the fan button here at the moment. The fan is not working here. Check on the back. Alright guys, one more thing I would like to test is I've not been able to find the fan, just to let you know, the button for the fan. So it seems like it kicks in automatically when the transformer is very hot, but I want to measure the voltage that is coming out of this inverter at this point. So we've got 229 volts coming out of this inverter, so which is really good. I don't have my scope meter at the moment to test the pure sine wave lines of this particular inverter, but that will come into play later on. But the most important thing for me now, having tested every other thing, is the fan. I'm gonna go through the manual to see if I can get the how I can trigger the fan to run. Just gonna pause this again.